It was during the autumn of 1986 that the contract to construct the Conwy section of the A55 was awarded to two of Britain's most highly respected civil engineering companies, Costain Civil Engineering and Tarmac Construction. It was the birth of a joint venture, both companies pooling their expertise and knowledge to undertake the most expensive and complex highway contract ever let in the United Kingdom. The Conwy crossing, known to most as the Conwy Tunnel, was born. The crossing will bring a permanent solution to a problem that has plagued this beautiful corner of North Wales for hundreds, if not thousands of years. It will mean for the first time the uninterrupted movement of traffic across the river and past the medieval walled town of Conwy. There is impressive evidence here of the work of civil engineers of centuries past. And one of the vital aspects of the scheme is to leave their masterpieces unharmed, unhindered. When the Conwy crossing is completed, the skills of today's civil engineer will be hidden under the estuary bed. But there will be equal acclaim for what he has achieved. He will certainly be applauded by local people, by industry, and by the millions of tourists who pour into North Wales each summer. For Conwy is as well known for its traffic jams as it is for its castle. Industry, tourism, local communities, everyone has suffered from the stranglehold of this curse of the 20th century. Soon, though, it will be a thing of the past. First of all, let's take a quick look at the scheme in its entirety. The 5.8-kilometre long section of dual carriageway runs westwards from Glan Conwy, alongside the river mudflats and under the existing causeway into the majestic watery expanse of the Conwy lower estuary. The river will be crossed by a 1-kilometre long immersed tube tunnel from which the road rises to cross the Conwy Morfa towards the Penmaen Bach tunnel. During the first 2 years of the contract, extensive earthwork operations have been carried out on both the east and west approaches to the tunnel. Where the new road has to pass over soft, wet areas of the estuary, large quantities of unsuitable material have been removed and replaced with blankets of rock. In addition to the tunnel itself, there are 16 other major structures to be completed. Starting at the east end, Bridge 1 is a 230-metre long 10-span viaduct. The abutments are founded on board cast-in-place piles, as are the piers. The embankments immediately behind the abutments are supported on reinforced concrete rafts. The other outstanding structure on the east approach is the M2, which allows the new route to pass below the Chester-Holyhead railway line and the existing causeway flyover. 4 bridges had to be built spanning the walls. Each had to be completed without disrupting traffic on either the main London to Holyhead railway line or the existing A55 trunk road. Without careful planning and considerable engineering skills, the whole of North Wales could easily have ground to an abrupt halt during the summer. Often the work had to be carried out with military-style precision and timing. A gigantic Bailey Bridge had to be constructed. Meanwhile, on the west side of the river, the road has to cross the railway for a second time, this time by an overbridge. Nearly 2,000 piles support the abutments and approach rafts. The bridge deck is made up of steel beams and concrete. The beams, incidentally, are manufactured in South Wales, so the Welsh economy benefits in other ways from the Conwy crossing. These beams were usually laid at night, when there was less traffic on the London to Holyhead railway line. Here again, timing and planning was vital. East of the railway bridge, the base of the M11 structure lies buried below a blanket of rock. This 300-metre-long reinforced concrete channel section will carry the new road over the soft peaty silts of the Conwy Morfa and in turn the link into Conwy over the new road via a bridge spanning the centre of the new structure. Without doubt, the approach roads either side of the river have given civil engineers problems never before faced in the history of major contracts. Future clients and road users will certainly benefit from the lessons learnt by Tarmac and Costain in tackling this project. Never before has there been so much sifting and shifting of sand, earth and clay. But the glamour and fascination lies out here with the bit in the middle. Beneath these waters will lie Britain's first immersed tube tunnel. Instead of burrowing beneath the estuary, the tunnel sections are being constructed on shore, then to be floated out and sunk into position.
The first year of the contract saw the formation of large earth bunds to protect excavations for the construction of the three primary elements of the tunnel. Sands dredged from the estuary were raised up and protected with rock to prevent erosion by the tide. Water is prevented from penetrating the bank by a continuous thin wall of bentonite cement injected into the bund, whilst behind the bunds a system of dewatering well points was installed. Ejector wells, to reduce pore pressure in the clays, made it possible to excavate the 1.4 million cubic meters of material to form the casting basin and cut and cover trenches. These enormous quantities of material, including clays and silt, are now being blended into the landscape or used to reclaim land. 300,000 cubic meters of the worst material was disposed of in the Irish Sea, using a purpose-built jetty and specially constructed barges.
This is where the giant tunnel sections are taking shape, and the scale of the operation is awe-inspiring. I'm standing some 14 meters below high water level of the river nearby. The space within these watertight walls could quite easily accommodate Wembley Stadium. It's difficult to imagine, but in little more than 2 years' time, these sections will be carrying the thousands of cars, coaches and lorries that daily pass across North Wales. The statistics are impressive. The 6 tunnel sections are twin reinforced concrete tubes, 118 metres long, 24 metres wide and 10.5 metres high. When completed, ready for floating out, they will each weigh around 30,000 tonnes.
The first stage of their construction is a 6mm thick coated membrane. The individual plates were fabricated in the steel shop adjacent to the casting basin and painted in the adjoining spray shop with a high-density polyurethane coating. The plates were welded together in place to provide the protective outer membrane for the unit floors and walls. Special steel end frames are built up on site as part of the joints between the individual units. Each unit is constructed in 10 bays. The floor bays each involve a 450 cubic metre concrete pour. Due to the thickness of the base, particularly at the haunches, care has to be taken to regulate temperature differentials during curing. Concrete temperatures are monitored by thermocouples installed within the concrete, and monitoring data is fed into a microcomputer. The tunnel walls are poured in single lifts, using mobile internal steel face shutters, and as the walls progress, the purpose-built roof shutter is installed to follow on closely behind wall construction. The roof again involves a concrete pour of 450 cubic meters, with the added difficulty that the end bays have to incorporate cast-in fabrications upon which the bollards and survey towers will be fixed. As you'll later see, these survey towers will be vital during the floating out process. Whilst the floors and walls are made waterproof by the coated steel membrane, the roof is protected by a torch-on bituminous membrane. This in turn will be protected by a 150mm layer of reinforced concrete. At this stage, the unit is structurally ready for its preparation for floating out. However, we must look to the ends and inside the units.
Steel bulkheads constructed across the ends of the tunnel bores seal off the tubes to make the buoyant caisson. To control this buoyancy, 4 pairs of ballast tanks will be constructed inside each unit. The tanks carry a total of 4 million litres, which can be regulated by a pumping system to vary the buoyancy during their float out into the river. At the leading end of the unit, shear keys are placed to fit into pockets constructed in the adjacent structure. And finally, a facing plate is welded onto the end frames and a synthetic rubber gasket is fixed to the face. This gasket will provide the primary seals to the tunnel as the units are placed in the trench. Either side of the river, the new structures being built will provide the approaches to the tunnel. Unlike the east cut and cover, which falls 9 meters steadily from ground level, the west cut and cover structure is constructed below a level of -10 meters. A ramp down to this level is provided by the M10 approach structure, some 216 meters in length. It was during construction of this section that engineers hit an unforeseen problem which threatened to set back the whole project. When excavation was almost complete, an unexpected artesian well was found. The solution was ingenious. Boreholes were sunk and pumps were installed. The water was cut off, flooding was prevented, and work could continue. Each section is linked by steel omega joints with 50mm stainless steel shear dowels. The final section forms the West Tunnel portal, the entrance to the Conwy Tunnel for traffic pouring in from northwest Wales and the Irish Republic. Once the floors and walls have been constructed, a volume of ballast concrete totaling 24,000 cubic meters is placed along the floor of the structures. When the east and west cut and cover sections and the M10 approach ramp are completed, the lower ends are blanked off with bulkheads and the structures backfilled. Then the protective bunds will have to be removed. The next step is excavating the trench between the two sections and opening a channel to link the trench with the casting basin. This work will be completed by a cutter suction dredger, which will lift sands from the riverbed and place them in large stockpiles on the existing sandbanks for use later on to fill the tunnel trench. Clays and other unsuitable materials will be pumped to the Glan Conwy reclamation area, 2 kilometers upstream from the tunnel works. When the 1.25 million cubic meters of waste material have been moved, everything is ready for the float out of the 6 tunnel units. This is how it will happen. As we've already pointed out, when the structural elements are completed, each unit is fitted with internal ballast tanks, bulkhead walls at each end, and a Gina gasket at the leading end. The tanks are then filled. When all the units are finished, the basin will be flooded, the bund wall removed, and an exit channel dredged. We are now ready to float out the units. Pontoons positioned over the units assist in controlling their relocation and final placing. At the exit to the basin, each unit will be fitted with a control tower, locating arms and bollards, ready for warping along the trench by a series of anchor piles set alongside in the riverbed. As they close in on their final position, the units are lowered to bring the leading face towards the end of the adjacent unit. The locating arm fixed to the roof guides the element, and they're drawn home by hydraulic winches. An initial seal is provided by the Gina gasket, and once the water is removed from the bulkheads, it will be compressed by a hydrostatic head of 2,500 tons. The remaining units are all brought into place, and a special closure piece made of 4 preformed sections is completed underwater around the ends of the 6th unit and the west cut and cover. With the tunnel in place, the trench will be backfilled with granular material and the riverbed reinstated to its original form. Inside the tunnel, the ballast tanks and bulkheads are removed and temporary joints will be made permanent. Ballast concrete will then be put down and ducts and cableways installed. Then it's a matter of laying the blacktop and painting the walls. And so the town of Conwy will be able to get back to normal. The rumbling of heavy plant will be silenced and the river will swallow the problem which has haunted the town for half a century or more. Everyone will benefit. Motorists will reach their destination quicker and local people will have peace, quiet and a new quality of life within these historic and majestic walls.